Alright, ladies and gentlemen, welcome back. This is going to be my last video, I think, for the logarithm exponential section. Are we all excited? Okay, I lied. It's not. We have one more that talks about exponential growth and decay, but that one I feel is the most important one that we've been leading up to because everybody hates word problems, and it's a tough section when you start throwing exponentials and logs because you need logs to undo exponentials and exponentials to undo logs. So what we're going to do now for this particular video is we're just going to solve log slash exponential problems. Equations, that is what I mean by problems. Exponential equations together. Because I feel like people get often confused about the comparison of the two. So we're going to try to do that so it makes much better sense when we deal with it. This is section 4.5 if for the Math 1800 section that at Wayne State University. So this is a problem I did earlier, and I probably should just pull it back up, or maybe do it again. Let's do it again. Log of x plus log of x plus 1 equals log of 2. Okay, this is going to be a log equation. Why do I know it's going to be a log equation? Because there's tons of logarithms everywhere. So in order, and this is, I'm going to draw a line down the middle here. In order to solve, oh, that's what I'm missing. The screen's all weird. Sorry, guys. So in order, why am I writing this if it's a recording? I'm not writing this. All right, so in order to solve this guy, we must use an exponential. What's an exponential? This means that already in my mindset, I'm thinking that for the log, this is my brain, base a of x equal to something over here, or I don't know, you can put whatever you want over here. I don't know, a house, whatever. Okay, in order to get this x by itself, I'm gonna need to do this. Base a both sides. This will undo this. X will be equal to a to the house. I know, right? Weird character. But that's what I'm already thinking I'm gonna have to do. And I don't know what's on the other side. It could be a whole bunch of logs. It could be a number. It could be roots. It could be something freaky. But in the end of the day, I know my logs are going to have to be consolidated together so I can use this property. So we're right so far? Now, when I have a function that has an exponential, it is just the exact opposite. When I solve an exponential function, okay, and this is probably the big comparison. If I'm solving a function, this is off the last video. If I'm solving this, right, the thing that's coming to my mind already, and I'm going to use my house, I love that house, is if I have something that looks like this, a to the x equals something, I don't know, you put it over here, b. All right, fine, whatever. I like my house. I'm going to put my house over here. House. Okay, bottom line is I need to find some way to break into this exponent, and we talked about this with exponentials in the last video for a big deal. I said it doesn't matter what base you use. If you have the option to use base 2, go for it, right? But you could use base 17. You could use base 5. It just comes down to the properties you're going to use. So what you're going to do in order to break into this, and I've seen people do this before, you have two options. To break into this, you can base a both sides, meaning it's the same base as what you see, house. This undo that, x equals log base a of the house. But the reason why I said this is often not usable, and it's often harder with notation, is because the log base a of the house thing, that's hard to put into a calculator, 1, and 2, writing that subscript of a, if you ever at one point in time dropped or forgot to write that a, you're screwed. Okay, so here I adopt the whole idea of log base, any base you want. Let's call it any, but that's not a. Call it, I don't know, smiley face. I know, right? I'm just being extra now. That's what people always tell me. Rush, you're being extra because you introduce all these weird symbols. Well, I feel like your generation, if you guys are from the millennial generation Xers, you guys invented hashtags, even though that's really a number sign, and smiley faces, and all these other emojis that you guys use in text messaging. So I figure I should use them in mathematical symbols. Why not? So bottom line is, log base smiley face, I can parachute this out, which gives me x log base a, base smiley face of a. That's why we don't use it. It takes too many pen strokes. Ugh. A smiley face of that stupid little house. So, and then divide by this number, which is just your log. Because remember, you're just searching to get the x by itself. House, blah, 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 blah. Divide by this. It's log base that of this. Okay, so bottom line is you get to choose what base you want. So that's the difference between the two. One, you're going to use a log to undo the exponential. The other one, you use an exponential to undo the log, right? So this is the two modes of which you must be able to set through. So let's go through and solve each one of the ones we have up here. First things first is I'm going to consolidate the logs. All the logs must be on one side in order to use this log property. Boom, done. X. Same base, so therefore we multiply the arguments. All right, it makes life a little wonderful. All right, now let's base 10 both sides. Why am I going to base 10 both sides? Because I recognize the base is 10 on everything. Yay. This will undo that log, so I get x times x plus 1. This just gives me 2. Now go. Easy, right? Here we go. You pick the base here. Okay, if you said 2, fine. I'm going to log base 2 both sides. That'll undo that. Leaves me x equals log base 2 of 17. Or I'm never going to use a base of 2. I'm going to be honest with you. I'm just going to ln everything. So natural log 2 to the x, natural log of 17, which are just numbers, parachuted out. X equals x times ln of 2 equals ln of 17. And then finally, divide by ln of 2. And we talked about this in the last video for a great deal, that I can, and I'll keep emphasizing on this, that I can put this into a calculator. I can't put this into a calculator. So when you guys start getting into chemistry and biology and physics, you'll notice they ln everything because they could put it into calculators. Life is much, 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 much better. So that's kind of the idea in the two. Very, very simple, but very, 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 remember I talked about this as well, that because they're so close, you got to look at the differences. To undo a log, you need an exponential. To undo an exponential, you need a log. Done and done. All right, so now let's stop talking about baby stuff, because you're like saying, Rush, this is overkill for this log base 2 of 8 thing. This is overkill. Why do I need to choose a base? Well, not for this one. That's easy. Let me show you which one's a pain in the neck. This one came from the final exam from our section 2008, and I figured it was such a great problem that I would show you guys how it works. So it's e to the x times x squared plus e to the x times x minus 2 e to the x equals 0. Congratulations. We must first try to figure out a way to solve this. To solve this, we have to factor, ladies and gentlemen. Yes, it is not that bad. Can it be bad? Absolutely. So I'm going to pull out e to the x because that's common. That means x squared plus x minus 2 equals 0. You can solve this. But we have to solve e to the x equals 0. So how do I undo e to the x equals 0? Dun, dun, dun. Natural log everything. Am I still recording? Yes, I am. Thank God. All right, I'm going to natural log everything. Why? And because this is log base e, I can undo that with no problem. So I'm going to ln e to the x. And I'm going to ln 0. Everyone's brain should be shooting off bells and whistles right now if you don't get it. Is this an answer? Absolutely not. Why not? Because we learned about the domain restriction on a log that b must be greater than 0, not equal to. So this is garbage. So your answers are only going to come from this, which is x. This factors. Beautiful. Those are your only two answers. It's beautiful. Not hard. It's beautiful. All right. So once again, exponential needed a log to undo the exponential. All right. Here's a good one, and I feel like this one's freaky deaky. E to the x, solve. E to the x plus 2 equals 3e to the negative x. So now you're probably looking at this like, what's good? Actually, better yet, this is a good time to pause the video and to try to solve it. Now, you already know in order to solve polynomials that look kind of like this, is you're going to have to put in some way of kind of factoring it, because that addition sign is killing everything. So, to pause the video and try to solve it, come back and then you'll see what I do. And it's actually quite creative. Alright, so if we look at this, you'll notice that you see an e to the x and e to the negative x. Okay, so this should not feel comfortable for many people, which I don't blame it. But you know, back in the algebra course, we talked about something called U substitution. And all U substitution was a way to make things feel more polynomial-like. They don't make them into polynomials, they make them feel more polynomial-like because we're more comfortable with them, right? So you notice I have e to the x in these two places. I'm just going to let u equal e to the x, just to make things easier. Then it means u plus 2 equals 3 over u, right? And then when that main comes through over u, can I solve this? Yeah, clear the fraction. I get u squared plus 2u equals 3. So u squared plus 2u minus 3 equals 0. U plus 3 and u minus 1 equals 0. So u plus 3 equals 0. U minus 1 equals 0. So u equals negative 3 and u equals 1. And then you're saying to yourself, okay, we must be done. Well, not really, because u is actually e to the x. We're solving for x. U is just a dummy variable to help us solve. Alright, so here we go. Oh, look, we have exponentials. What do we need in order to solve for an exponential? A log. What base am I probably going to use? Base e. Why? Because there's a base e here. So I'm going to natural log both sides. Boom, bells and whistles. I should go no further. This must be positive. This is not going to work. So if you have x equals ln of negative 3, this is garbage. So e to the x equals 1. ln both sides. X equals ln of 1, since that's going to undo this. And then, oh look, this simplifies. E to what exponent is 1? 0. Your only answer for this entire polynomial is 0. Isn't that something? So this is not really that hard, but these are definitely different concepts that you guys are going to have to deal with as we transition through different things. All right, now last but not least, I think we have time for one more. Since this is actually just a 12-minute video, I think I'm going to put in one more. Now, this one is not that hard, and as a matter of fact, I always put one like this on my exams because I feel like if you could do this, you are golden. Okay, solve this guy. And I'm going to tell you to pause the video and come back and see what I do, if you can or you can't. Okay? Alright, so I'm assuming you guys paused the video and you tried. So check this out. We need to solve for x. The problem is what base do I use? How do I, like, seriously, I have a base of 2. I have a base of 6. I got this coefficient in front of the 2, which is a 3. So what the heck do I do? Well, good news for you is you know in order to solve an exponential, you need a logarithm. Well, in order to use this logarithm on this particular thing, what you're going to need to do, first of all, is look at it and say, okay, there's no addition anywhere. And there's a reason why I couldn't log this guy on both sides. There's a reason why. Because if I do log ln of x squared plus 2 and ln of 3e to the negative x, I could kind of muscle this a little bit, which is fine, but this is garbage. This takes me nowhere because remember, this has to be multiplication in here. Remember, log base a of x times y is equal to log base a of x plus log base a of y. So the addition, once again, is notorious for shutting things down. So do not fall trap. That's why when that's addition there, my first thought was use u sub. So we were talking about strategies behind solving. This is all the reasoning behind why this one was a u sub problem. While this one, see how there's a multiplication here already? I'm going to go right at it. I'm going to natural log it. And why am I going to natural log it? Because I see my foreshadowed thought. Oop, I need a ln one side and one on one side. My natural thought is I know from here to here I'm going to use that ln of x times y, right? Log base e of x times y is the same thing as ln of x plus ln of y. So this becomes ln of 3 plus ln of 2 to the negative x equals ln of 6 to the 3x. Now, where am I going to go? Remember, I'm still solving for x, so I'm stripping stuff off of it one by one. Now, I also know that if I have ln of x to the y, I'm going to parachute the stuff on the outside out. All right? So I could parachute this crap out. So this gives me ln of 3 minus x ln of 2. Where did I get the minus from? Negative x equals 3x ln of 6. Now I need to solve for x. So I'm going to put all my x on one side. In the spirit of keeping things positive, I'm going to add that over. ln of 3 equals 3x ln of 6 plus x ln of 2. I'm going to factor these x's out. So I end up getting x 3 ln of 6 plus ln of 2 ln of 3, and then divide by that number, which is some nonsense. Well, not nonsense, but it's irrational. I have a tendency to call things nonsense. And then we're done. Now, obviously, if you're a deep thinker, which I know some of you guys are, you're probably saying to yourself, well, I can simplify this guy down. Yes, you could. You could call this ln of 3, and then in the denominator, parachute this 3 back in. But it complicates things because you are done. Why do more work? And then finally multiply the two together, which is ln of 3 over, I don't even know what that is, 532. Oh, no, 432. 432. So this would be the simplified answer, simply simplified answer. But this is adequate, guys. Don't overdo it. That's it. All right. So once again, solving equation, yes, it gets freakier and freakier and freakier. There are just many different concepts. There's U sub, which you already knew of. There's factoring by grouping. There's just factoring in general. And then if you don't have any addition in there, then feel free to just log the mess out of it. But it is good to go, okay, guys? So once again, if you ever want to do something that you have never, or if you ever want to go, if you've ever gone some, what is the saying? If you want to go somewhere you've never been, you're going to have to do some things you've never done, guys. So please, push yourself, make yourself uncomfortable. I will see you on the next video. Once again, this is Rush Mahar from Wayne State University, signing off.